Good morning, dear kids. Today I'm taking you exercise 10.4, problem number 2, which says if two equal chords of a circle intersect within a circle. So if I have this as a circle and there are two equal chords. So these are the chords and they are equal. That is, can I write it as A, B, C, D? They are equal and they intersect within a circle. So I'll put this as E. Prove that the segments of one chord are equal to the corresponding segments of other chord. That means you have to prove that AE is equal to DE. I'll mark it so that you understand. You have to prove AE, which is corresponding to ED, and you have to prove CE is equal to EB. That is the meaning of prove that the segments of one chord are equal to the corresponding segment of other chord. तो ये अगर chord है तो उसके जो बीच हिस्से ये अगर दो chords हैं, so these will be called as segments. Are you getting my point? So in a way, I'll write it here. You have to prove that AE is equal to DE and CE is equal to BE. For that, you require a construction, that is, from the center, you have to draw perpendicular to AB. I'll put a center here and I'll draw perpendicular to AB. And similarly, you have to draw a perpendicular to CD. Shall we name it as M and N? Yes? Okay. Now, in that, you also have to join this. We'll name this as center O. So OE you have to join. Got my point clear? Now you have to prove. So how you will prove now? If I suppose take, Acha, do you remember in my previous session I have made clear that when we draw perpendicular from center to chord, it divides the chord in two equal halves. So OM is perpendicular to AB. That means AM will be equal to MB. Can I just put it an arrow and equation number 1? And ON is perpendicular to CD. That means CN is equal to ND. Yes? Clear with this? Okay. Next we have, and they both are equal chords. We know that very well. So we can also put it like if they are equal chords. So AM is equal to CN, MB is equal to ND. Means all the parts are equal to each other. Okay. Now if I take two triangles, I'll prefer to take two triangles, that is OME and ONE. So if I want to go for in these two triangles, in triangle OME and triangle ONE, you will get three reasons to prove them congruent. Can we? Yes, your one reason is angle OME is equal to angle ONE because both are 90 degree. OE is equal to OE because that's a common segment in both the triangles. Next you have, okay, what do you have next? OM is equal to ON. Why? Because if the chords are same, then their distance from the chord, they are equidistant. So we can write equal chords are always equidistant from the center. We have proved this theorem in my previous session. Equidistant from center. So you got three reasons. Okay. So once you got three reasons, therefore triangle OME is congruent to triangle ONE. Can we go for RHS test? Will that work? Yes, RHS test. It is right angle hypotenuse. Can we then take ME is equal to EN by CPCT? By CPCT. Okay. Now your ME is equal to EN. And you know very well that AM is equal to ND because they are the two halves of two equal chords. So AM is equal to ND, and now you have proved ME is equal to EN. If I add these both things, I'll get AE is equal to DE. Am I correct with this? Yes, so your first thing is proved here. Now you want to prove that CE is equal to, that is this part is equal to this part. We know that CN is equal to BM. CN is equal to BM because even these are equal parts, the two halves of two equal chords, so they are equal. Now we already have ME. Okay, CN. Okay, we have EN is equal to ME, so we'll write EN is equal to ME. Now in my previous equation I have added, but for my second proving I'll subtract these two. If I subtract Cn minus En, so I'll get Ce. And if I subtract Bn, look at the figure so you'll get it. En, sorry. So your next is Bn minus Me. From where does this Bn came? It's not Bn. Me is this. Okay. Bm it is. Bm minus Me. So you will get Be. And hence proved. Clear? Next we have, if there are two equal chords of a circle intersecting within the circle, then you have to prove that the line joining the point of intersection to the circle makes equal angles with the chords. Let's draw the figure so that we will understand. We have a circle and two equal chords. If I take this and this, we'll name it as A, B, C, D. They intersect at point E. The same figure I'm drawing which I drawn in my previous question. So we have, if two equal chords of a circle intersect within a circle, prove that line joining the point of intersection to the center makes equal angles with the chords. Now if this is a center, so can we say EO is the line joining the intersection of the two chords and the center? This makes equal angles. That means you have to prove that BEO is equal to EOC. Getting my point? For that, you have to draw again a perpendicular, and here also perpendicular construction. You can name it as M and N. Now for that, you can take these two triangles congruent. That is, you have to go in triangle MOE and triangle NOE. In that, your first reason OM is equal to ON, because if AB is equal to CD, then they are equidistant from the center. So center से जो उनका distance perpendicular आया, which is drawn from the center to the chords, that is the distance from the center of two equal chords is always equal. So they are equidistant from center. Your second reason is EO is equal to EO, common chord, common segment. Next is your angle OME is equal to angle ONE. Both are 90 degree. So you got three reasons. Therefore, triangle MOE is congruent to triangle NOE by RHS test. Now, once they are congruent, can I say therefore angle MEO is congruent to angle NEO by CPCT. And that's what we wanted to prove. We wanted this angle to be equal to this angle. MEO NEO. Got my point clear? Your next is if a line intersects two concentric circles. So your concentric circles are like this with the same center. With center O, so we'll mark it as O, at A, B, C, D. So in your book, figure is given to you A, B, sorry, this is C, this is D. Okay. You have to prove that AB is equal to CD. If I draw perpendicular from center to the chord and name it as OM, in my small circle, you can notice that OM is perpendicular to BC, therefore BM is equal to MC. Why? Because perpendicular drawn from center to chord divides the chord in two equal halves. And again, if we see in our bigger circle, OM is perpendicular to the bigger chord AB. Therefore, AM is equal to MD. Again, the reason is same. Perpendicular drawn from center to chord divides the chord in two equal halves. This is your equation number 2. This is your equation number 1. You have to subtract 1 from 2. So it will be AM minus BM, your left hand side subtraction, and your right hand side MD minus MC. Got my point clear? बीच में is equal to जैसा है सब में. Okay, so here you will get AB and MD minus MC will be CD. Hence proved.